Hello friends, this is Tele Logic Jones back with this is actually a replacement video. I released these videos on the Lunar Rover quite a few months ago now, and just recently re-watched and had to cringe a little bit at how rushed and pretty messy video. So I apologize for anybody who tried to watch it before, and I can understand why you might have just said, what is even going on here? Even just the audio was disconnected with the video too much, such that I was making comments on things that were not happening on screen. But it also gave me a chance maybe to make a briefer video than I had before. And this is, as I said in the first video, somewhat of a new direction for me. It's sort of a little concerning going down this road, and I've already had some interaction online recently with somebody at the Stephen Cox Big Bang video with the guy from the Colby Center, Christian Bergsma, and a very informative video. But I had some interaction with a guy in the chat, or in the comments after the posting, and I mean, just people are just not willing to go here, and it's understandable. It's understandable to a certain point, but at another point, you have to realize that you need evidence for the event if you're going to say the event took place. And that evidence better be good. And the only evidence we have is the audiovisual record. And the question is here then, how good is the audiovisual record at representing being a documentation of events on the moon? In this case, we're going to be looking at the Lunar Rover. And what is its status as a documentation of that event? And there are there are two variables that we need to be looking at when we're considering where is this vehicle that's moving here. I'll get it moving so we can carry that conversation on. It'll start moving in a bit here. I think it's started now. So what is the two variables that we need to keep in mind when we're looking at this vehicle moving here is the differences between the moon environment, or at least the supposed moon environment, and the Earth environment are going to be force of gravity and atmosphere. Now, on the Earth, we're going to have the force of gravity we experience, and we have a way of, we say that a 10-pound object weighs 10 pounds because we weigh it on a scale and it weighs 10 pounds. Now, on the moon, let's make it instead a 60-pound object. So on the moon, we're going to find out that everything is going to be 1/6 in terms of weight and in terms of time of fall, because the gravity is said to be 1/6, and this isn't conspiratorial. This is the facts or the supposed facts that are given to us by those who claim to have gone there and claim that this vehicle is moving around in that environment. So basically, if something weighs 60 pounds on Earth, it's going to weigh 10 pounds on the moon. We also know that objects on the moon are going to be moving are going to fall at 1/6 the speed. So this is according to the Newtonian physics, and according to because of the mass of the moon is 1/6 of that of Earth, so therefore the attraction of the moon is 1/6 that of Earth. And so weight is 1/6, and velocity or accelerative velocity at any given time is going to be 1/6. We will get into more detail, well, extensive detail of that in the following videos, which have already been done, which I think still hold up fairly well. I'm not going to redo those videos. But the other factor is going to be atmosphere. Now, the atmosphere on the Earth is what it is, and we experience it as we do, and we understand that it's present, and in some conditions of, say, throwing an object, we hardly notice it, but in other conditions of throwing an object or objects, we do notice it, such as if we throw a baseball. There is some effect, obviously. I mean, a pitcher realizes that if he puts spin on a ball, it's not the ball itself spinning that is causing it to curve. Though I may be wrong on that. There might be some gyro effect there. But we understand that it's going to, if a ball is hit out into the outfield, wind will affect where it ends up going. So smaller objects will be, and less massive objects will be affected by wind, and larger, more massive objects, or just more massive objects, will be less affected by wind or atmosphere. Even just the air itself will slow objects down. Drop a sheet of paper and it'll kind of, depending on how it falls, if it falls edge down, it might fall pretty straight, but it probably will start to curve. Sometimes it'll even turn 90 degrees before it hits the ground and begin to sweep around. So atmosphere does have an effect. Now on the moon, there is effectively zero atmosphere. For any object falling, you would drop a sheet of paper, the sheet of paper would just fall. You would drop, you hit a baseball, it would be unaffected. It would just simply fly through the air, according to its sort of perfect parabolic arc, without any effect of atmosphere. So these two factors we need to be able to, or two variables, we should be able to see clearly a difference between what we experience on Earth and what is experienced in this documentation on the moon. And we're just letting it play here so you can become habituated to what's going on here. Now, intuitively, as we watch this buggy moving along here, we can ask ourselves a question about, intuitively, how do we feel about these images? Now, this part of the travel, this is the onboard camera, seems to be a normal kind of motion. I don't see anything about this motion that seems to be problematic, other than it's latent right here. It just seems to be documentation of a vehicle moving. And yet this seems very slow here. Maybe it's just moving slow. But the motions seem kind of slow-mo to me. And I'm hardly the first person to point this out. There is something just kind of not quite right here. So we say, oh yeah, we're on the moon. So, it could be that it's just something's different happening here that's it's not like on Earth, but we already have our variables that we should be expecting to change. The variable changes are going to be mass of the moon is less, therefore gravity, according to the theory, will be less. That means objects are lighter and fall slower. That means they stay also, a thrown object on the moon will at the same thrown at the same velocity or the same vector will travel 6 times as far, will go up in the air 6 times as high as on Earth, and go 6 times as far. That's what it means, and it will weigh 6 times less if we put it on a scale. And also we know there will be no atmosphere. So neither of these things should of these variables should have anything to do with the speed of travel of the buggy. In fact, it should move along just at the same speed with the amount of gas, other than the fact that it won't be holding to the ground quite as firmly. But look here, there's nothing here happening that says this isn't holding to the ground firmly. It's tucking in just fine to the ground, and we can get that sense here when it's moving what appears to be at normal speed. Although we can't see the vehicle head on moving, we get this kind of object in front of us here giving us an indication of the location. It's just moving, and it's bouncing up and down just like we would expect. There's nothing. Imagine 6 times. So you hit a bump at a certain velocity, and it throws you up in the air. And imagine you're hitting a bump, and you go up a certain altitude based on the bump, and then you come down, and the speed should be about the same. The rise speed should be kind of equal to the descent speed. So through the apex, and that's happening constantly on this vehicle here. Do we notice anything that's 6 times different than what we'd expect on the Earth? In fact, we understand something that's less. Look at that there, right through there. Let's look at that again. Yeah, watch this section as he comes through here, as he begins to do this serious bouncing. Now the bouncing is slower than we'd expect, but right here, there's nothing 6 times about anything, that it's taking 6 times as long or that it's accomplishing 6 times the distance. This is a very intuitional take, I understand, and that may not be that satisfying yet, but there's a couple other things we're going to look at here that are a little more, a little heavier kind of gotcha indicators as we look at the buggy. Now, the question was, what's happening here in terms of this footage? Now, we know this is a documentation of something, so it will tell us the truth about the environment that it's being filmed in. Is this just, some kind of NASA backlot thing on Earth? There's no reason it couldn't be, based on what we're looking at here. There's nothing incredible here other than this kind of obvious moon crater thrown here. And we know they made fake moon backlots before they went on the landing for practices, or at least they claim to have done so for their practices. So this would not be completely out of touch to say that this is a NASA backlot. I mean, even this sort of blackness above the skyline, this is all easily achievable. There's nothing remarkable about the footage that tells us, oh my goodness, we must be there. And in fact, there's something kind of cheap about the whole thing. Thankfully, somebody who is devoted to the NASA missions has gone and made this Steadicam, or this steadied camera version, as you can see if you look at the perimeter. And now we're going to look at, if you looked at the perimeter there, you could see that of the film, you could see that it was dancing around pretty good. You can see it dancing around pretty good here. And it makes it a lot easier to watch. In the old days, you had to watch this thing. And it added, though, to the confusion. The question is, why? Why is this guy holding the camera? What has he got? Got DTs or something? Why has he got the jitters so bad that he can't just hold a camera? I guess it's supposedly on his chest or something. I don't know. Anyway, you'd think they'd go through the effort of trying to make it look a little better. But this guy, somebody, and I posted it in the description. I posted a link to the video, and it's never been taken down, or I've never had anybody coming after me over it. So there we are. In this next section, we're going to look at the speed of the thing. Now I slowed it down at this point for some reason. When we'll look at atmosphere next, but the first one we want to have a look at here is just the speed of the thing. Now what it's going to do when I resume the play here is it's going to start playing, running along at about 1.5 times, and or 1.25 times, I think. But anyway, we're speeding up the thing, and you'll see how much more natural the movements are, and how much they are just like anything you would expect on Earth. There's nothing super special about what we're seeing that looks like it's in the kind of environment we were expecting. An environment, in this case, we're dealing with the acceleration of gravity, and also the and therefore the time duration of throw events, which we have actually quite a few, as it were, parabolic events, in that the vehicle is going up and down, so that whatever force forces the tire here up, because it's moving along, hitting a bump, going up, it's going to go up at the speed and down at the same speed, up at the speed, down at the same speed. And on the moon, we should expect at the same speed, hitting at the same velocity, running along this way, hitting an object that's going to cause it to go up. It's going to go up. There's going to be some variation because it weighs less. It's not hugging the ground as much, so it's not, but that's only going to cause it to go higher, perhaps, not less high. But for now, we'll just assume 6 times. So whatever a bump is here that should send it up and going, it's going to go up 6 times higher. If it's going to go up this high on the Earth, let's start down here. If it's going to go up, say, a tire, the rubber tire part on the Earth, it's going to go up 6 of those. 1, 2, 3, 4. It's going to go about a full tire height on the moon. Are we going to see anything like that happening here? I think our highest arc is maybe this high. I mean, it looks higher always when you watch this stuff, but it's not very high. But is there anything 6 times about it? And ask, why does it make sense that for this documentation, how come speeding it up to 1.5 makes it look more natural? How does that relate to 6 times? Again, all movements this way, all movements forward, or any movement, any direction, are going to be unaffected by the change in gravity. The only effect is going to be suspension in air, duration of time of fall. And we'll go through this in much greater detail later. But if an event is going to go this far, well, let's make it a little less, about this far, it's going to go 6 times on the moon. 6 times. So as the buggy goes up and back down, it's going to go up and back down on Earth. It's going to go up and back down on the moon. It's a significant difference. And so how does speeding it up by 1/4 or 1/2 or even double make it look like just a normal event on Earth? Well, the math doesn't work there. First of all, it's double. Second, why are the motions laterally should have no change? The only difference should be suspension in the air. So let's watch this. So here we go. We see it sped up. As we saw before, as it would go up and down, it looked like it was moving up and down in slow motion and moving in slow motion, and it seemed like it's moving too much. But this is just the kind of normal speed of looking like the normal speed of a dune buggy, or closer to the normal speed of a dune buggy. It's got quite a bit of weight to it, which, how on earth did they get such a massive object up onto the moon with them? in that tiny little thing they were in. I'm not sure if there's a full narrative explanation for that. As we can see coming back here, that these seem to be more in line with the speed of the bumping that we're seeing at the higher frame rate when we sped things up. Now, let's have another look, or let's have a look at a comparison. I found this great video called Catch the Joy, which is a doom buggy documentary from 1970. And it'll start here in a sec. And it'll give us a chance to see what things look like. That to me actually looked like they made that go in slow motion. And this is my free helicopter shot. I mean, this probably cost them, what would be the equivalent of thousands of dollars today. I've got a golden hour helicopter shot for free. Oh, look at that. Look at that. Oh, nothing beats it. And so we can look here at these vehicles moving along in the sand here, and they are looking, quite similar to what we see our dune buggy doing sped up, or I say our moon buggy doing while it's sped up. And we see the look at this. Wow. Okay. Solar flares and all, just straight off the internet. The video quality is pretty poor, true enough. And we see, though, that they are kind of staccato when they're bumping around on stuff. But we also see something that we want to start talking about, and that is air resistance. And that was just a great documentation of it there. Again, we're going to see that happen again. We'll pause it when it happens so we can discuss this a little bit more. But look at this. There we go. Why is this cloud happening in this way, and that we have all kinds of forms coming out of it? It almost becomes chaotic. Well, we've got resistance of the air. So you're imagining you've got all of these projectiles coming off the back end of the tires, and as they go through the air, some of them are fine and some of them are more coarse, and the finer ones will slow down more quickly than the coarse ones. They will be slowed more easily, I should say. And then the bigger ones will run into them, and then the following smaller ones will run into, and you will just end up with this kind of wave resistance that is seen here in all of these cases. You can see it happening. In each of these cases, you can see this air resistance causing these waves. And on Earth, of course, that's not a problem. We expect that on Earth. We even expect the way it falls slowly there to just be part of what we would expect on Earth. And because it's suspended in the atmosphere. But on the moon, when we get back to the moon, and we'll see as it gets moving here on the moon, there's no reason to expect there to be any air resistance whatsoever. And we can start seeing it right here. Watch as this moves along. Look at what is happening here. Watch this do its thing as we move along. We see we know the gravel is being, or we intuit that the gravel is being pulled up by these metal mesh tires. And there it's going through here, and then it's being blown down here. But why is it coming out like this, and why does it sort of hold a pattern and come down? Watch this happen here. See that? That's atmosphere. That's not the only indication of atmosphere. Look what's happening out of the back of the thing. how it pauses. It goes up in the air, and it forms waves. You can see the waves forming as the same kind of resistance. Now it's not chucking sand like that thing trying to run up that hill was doing. But watch as it comes through here. You can see clear indications of atmosphere. Look at this. That's clear indication of this is very similar to what we saw. And to explain what should be happening here, if I can do this with this drawing tool, pardon the vulgar quality of my drawing here, but this is what we should be expecting to happen. There's no reason for the projectiles to do anything like what we're seeing here, and we'll look at these again in motion. They should be simply perfect projectiles. And not only that, this is a perfectly reasonable amount of distance for something to be traveling on Earth, whereas we should be expecting 6 times the throw on the Moon. This is one of the most damning parts of this documentation in terms of, is it a documentation of events on the Moon as described as the conditions on the Moon? That is, a place of 1/6 gravity without atmosphere. And we see 2 aspects failing here, hard failing. One, we don't have perfect parabolic arcs, which is what we should expect, because we have atmospheric resistance. You can see it hitting up against the atmosphere here, and we can see that again happening later. But we also see it's not going, that's the one variable, atmosphere, fail on atmosphere. We also see that there's a failure in terms of projection. It should be 6 times. I mean, I've not even done it here. If this is how high it's gone, it should be 6 times that high. It should be way, way up here, and then 6 times this distance. And we'll get into this more in the math portion of the next few videos. This is not an event in an environment as described. This is quite simply an event on Earth. There is no way of saying that this is an event in 1/6 gravity with no atmosphere. The documentation we're given does not offer us the luxury of that interpretation. So when we say, show us the evidence, here we go. Here is let me get this back here. That's the other part I meant to discuss before I rambled off. So watch as it comes through over here. Again, the resistance waves are very clear. I mean, you can see them all through here. There's the one we saw before. Now they come through here, resistance waves, and these ones are just like clear. Look at that. Again, watch it as it comes through here. There we see them. Here we see them. I mean, they're obviously there. Once they're somewhere, they're everywhere. It's not like they can disappear. Look at that. And right through here, look at this. These are clear resistance waves. Again, what we should expect is one simple thing. We should expect a parabolic arc like that. There's no reason on the Moon to expect anything other than this. Why do we have this? And even if these are somehow the indications of the way the tire is throwing it in waves, these things shouldn't come up here. Look at how they shouldn't come up here and dissipate and then fall down. They should always continue in an arc, and even more, or just as importantly, they should be 6 times further. So the thing that we have here is, like, often what is said, outstanding claims require outstanding proof. And that's, if you're going to claim the moon landings are fake, you need outstanding proof. Well, that actually inverts the question, or it inverts the burden, the side that needs the burden of proof. Quite honestly, to say that man went to the moon, that's the outrageous claim. It doesn't matter whether a big state or big state operations. In fact, that makes you want to be more question it even more, especially during the Cold War. The outrageous claim is that man went to the moon. And, okay, I've made an outrageous claim. I've said that this is... I can't say man didn't go to the moon, because maybe they went some other way. But the documentation that they've given me, my claim is that the documentation of man on the moon is not of the moon environment, because it fails to meet the criteria of atmosphere and of, because we have these resistance waves, and it fails to meet the criteria of gravitational force being reduced to 1/6. And that could be, if somebody really wanted to get scientific or technical about this, you could go through the mass of the vehicle and talk about the velocity of the descent after bumps. There'd be a way of doing a really, really solid analysis of this movement of this vehicle to see whether or not it conforms to 1/6 gravity. But by intuition alone, it doesn't. And by a more technical look, as we will look at those aspects more clearly later, it doesn't. This is not happening. These waves here, even if these were produced on a non-atmosphere moon, or a moon with produced within zero atmosphere, they should carry on as they are over in a perfect parabolic arc, and they don't. They rise up and flatten out and descend. They don't carry on in this perfect parabolic arc, nor do they carry on at the altitude that we should expect them to in the moon environment of 1/6 gravity. Well, I was hoping to keep this short. I don't know how short it's going to be in the end, but those are the points that we want to make here. Let's get this thing moving again. And just look at all of the indications here. And again, why this is moving along at a normal speed, whereas our buggy, when we're looking at it from the outside rather than from within the buggy, moves along at a very different kind of speed. Like these ups and downs are just up and down, just like you would expect if you were riding on a buggy like that. It's kind of jolty. It's not a comfortable ride. Whereas it's kind of moon glide ride here at slow-mo. And again, the atmosphere around the tires. Look at that right there. More atmosphere, clear atmosphere. This is such a gross C-grade deception. And yet, to say you deny it, people just cut you off. They want to have nothing more to do with you because you've denied this thing. And yet, in terms of, detriment to faith, this thing is detriment to faith. This has been a massive justification for the Newtonian naturalistic world. It's like not an incarnation, but an immechanation of the Newtonian naturalistic world. And even though they know Newton doesn't work, and doesn't work according to their new principles, they have to hold on to Newton because they need to have a tradition that continues. Quite ironically, they need almost for it to be trad. Newton is sort of like trad physics. They keep him around, try to make it work, but if you look at my other work, Newton's never worked. I probably get that in. I do get into that a little bit in the other videos. So this is just a way of introducing this, I hope, with some clarity. I mean, if you think I'm a loon, well, then you think I'm a loon. But this is loony, as far as I'm concerned. And people don't want to look at it. I mean, I don't think anybody who actually holds a strong conviction in the moon landings, or at least socially will hold a conviction, has spent much of any time watching the actual footage. Because it's terrible. Like, this is... Look at that. This is a slow motion shot, or a slow motion presentation of a buggy on Earth, and it gives all indications of just being on Earth. Anyway, that's the end of this video. Thank you so much for watching, and I will continue in this work, and there will be book links. I'm currently re-editing the restoration, which was my kind of big work. I didn't have a lot of readership, and I'm kind of glad I didn't, because I've since publishing it become more convinced of geocentrism, not more convinced, been completely converted to geocentrism, and for reasons kind of that I can't really get into now, because it's another work that I'm working on that I want to present whole and on its own. It's a work on geocentric observation, which I do cover in the book. In chapter 2 of the restoration, I introduce the concepts of geocentric observation, but I will more introduce the concepts of, what I've done this summer is spent some time actually practicing geocentric observation more pointedly, and have made some very interesting discoveries about the sun and how we can scale the size of this, the distance of the sun from the Earth. And it scales much closer to Earth than 97 million miles. But that's only a teaser. We'll get some details out. I have to work on that work, and I more than metaphorically swing a hammer for a living day by day. So my time is somewhat limited. I'm sort of semi-retired, not semi-retired. I don't have to work a full week anymore to get by, shall we say. So, but I don't have a lot of time to do this work. It's one of the reasons why the first video was kind of garbage grade. But I hope this one's clear, and thank you again, as I said, for watching. And anybody wants to chat with me about this or have me on for an interview, I'd be more than welcome. I'd be more than willing to come on to any show and have a chat. I have been on the Sede Picante's show a couple times, but nothing other than that. Anyway, God bless, and this is teleologic